All right, team, welcome. Let's get started. The goal today is simple. Get us all on the same page for fine-tuning these DeepSeek models. I know it looks like a huge technical lift on paper, but we're going to walk through exactly how we're going to nail it.
So this is the big question, right? How in the world are we going to fine-tune a 70 billion parameter model on a single GPU? Normally, you'd be looking at a whole cluster of machines for something like this, which, well, we don't have. But the plan we're about to go through, it makes this totally possible on just one machine. Seriously.
Okay, so here's our game plan. It's a 5-step process. We'll kick things off with why we picked DeepSeek in the first place. Then we'll dive into the secret sauce, our QLoRA playbook. After that, we'll talk data, the tools and hardware we need, and finally, how we get this thing from training into production.
All right, let's jump into part 1, the mission. Look, choosing the right base model, it's probably the most important decision we'll make. It sets the foundation for everything else, and that's exactly why we're betting on the DeepSeek family.
So what makes DeepSeek so special? It's all about its architecture, specifically something called Mixture of Experts, or MOE. Now, a standard model is kind of dumb. It uses its entire brain for every single token it processes. Super inefficient. But an MOE model, it's way smarter. Think of it like this. Instead of one generalist trying to do everything, you have a team of highly trained specialists. A little router inside the model looks at the task and says, okay, you, and you, the experts in this area, go handle this. So we get all the power of a massive model, but with the speed and efficiency of a much smaller one. It's a game changer.
So, that brings us to the next question. Which specialist do we hire for the job? The DeepSeek family gives us a fantastic lineup to choose from. For example, if we're building a new dev tool, DeepSeek Coder V2 is a no-brainer. It's already best in class for code generation. If we're aiming for a super smart chatbot, we'd probably start with V3.1. The key takeaway here is that we're not starting from scratch. We're picking a foundation that's already 80% of the way to our final goal.
Okay, so we've got the model. It's efficient, it's powerful, but how do we actually train it? That brings us to the core of our strategy, the QLoRA playbook. This is the magic that makes this whole thing possible on the hardware we actually have.
So what is QLoRA? It stands for Quantized Low-Rank Adaptation. It's a really clever technique that basically smashes two great ideas together. First, you have LoRA, which is this idea of freezing the giant base model and just training a few tiny adapter layers on top. Then you have quantization, which is a fancy way of saying we shrink the model down so it takes up way less memory. You put them together and you get QLoRA, and that is what makes this entire project possible for us.
Okay, so what does that actually look like in practice? It's a simple 3-step process. Step 1, we take that giant base model and load it into the GPU. But we quantize it. We shrink it down into a super efficient 4-bit format. Step 2, we bolt on these small, trainable LoRA adapters. And here's the crucial part. Step 3, we only train the adapters. The original model, all those billions of parameters, stays completely frozen. So we're not rewriting an encyclopedia, we're just adding a few, very precise, very smart sticky notes to it.
And what's the payoff for all this cleverness? How about this? A roughly 94% reduction in VRAM usage. Let me put that in perspective. A full fine-tune of a model this size would need over 780 gigs of VRAM. With QLoRA, we can do it with less than 48. I mean, that's not just an improvement, that's a complete paradigm shift. It's what takes this from impossible to let's do this.
Okay, we've got the engine, that's the DeepSeek model. We've got the tuning process, that's QLoRA. Now we need to talk about the most important part, the fuel, our data. And I really can't stress this enough, team. The quality of the data we feed this model will make or break this project. It's more important than anything else.
This quote here really nails it. Remember, we are not trying to teach the model new knowledge. It's already read the entire internet. It knows facts. What we're doing is teaching it a behavior, a specific style, a specific format, how to respond in a very particular way. All the research and all our experience shows that a few hundred, maybe a couple thousand, absolutely perfect examples are infinitely better than a million mediocre ones. So our mantra for this phase is simple: quality, 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 not quantity.
So this is our checklist, our marching orders for data prep. We're going to standardize on the JSON lines format, or JSON-L. We'll use a clear conversational or instruction-based structure. Cleaning is non-negotiable. We have to be absolutely ruthless about deduplicating, getting rid of noise, and scrubbing any and all PII. And for sourcing, we'll either leverage high-quality open-source datasets, or, even better, generate our own synthetic data based on a handful of gold standard examples we create ourselves.
All right, data principles are set. Let's move on to the blueprint, the nuts and bolts. What specific tools and hardware are we actually going to need to pull this off?
And the good news here is we don't have to reinvent the wheel. We're going to be leaning heavily on the Hugging Face ecosystem. I mean, it's the industry standard for a reason. Libraries like Transformers, PEFT for QLoRA, and TRL for the trainer, they're going to do all the heavy lifting for us. Under the hood, Bits and Bytes will handle the 4-bit magic. It's a proven, robust tech stack, so we can focus on the data and the model, not the plumbing.
Okay, so that's the software. Now, let's translate this into a concrete hardware plan. This is where the rubber really meets the road, and we answer that big question from the beginning.
And just look at this. The numbers are actually pretty amazing. Using 4-bit QLoRA, you can fine-tune a 33 billion parameter model on a high-end gaming card like a 3090 or 4090. For our target, the 70 billion parameter model, we're looking at around 46 gigs of VRAM. That puts it squarely in the territory of a single enterprise GPU like an A6000 or an A100. So this isn't theory. This chart confirms that our plan is absolutely feasible on the hardware we have access to.
All right, team, we're in the home stretch. Let's talk about execution. This is where we cover the final steps, how we tune this thing and how we get it deployed.
I want to save us all a bunch of time on trial and error. So here's our starting hyperparameter cheat sheet. We're not going to start from scratch. We'll kick off with a learning rate of 2e-4. We'll stick to just 2 epochs to avoid overfitting, and for the LoRa-specific stuff, we'll start with a rank of 16 and an alpha of 32. This is a really solid, well-tested baseline that will get us 90% of the way there and let us focus our experiments where they matter most.
Once training is done, our path to production is super straightforward. 3 steps. First, evaluate. We have to prove, with data, that our new model is actually better than the original on a test set it's never seen before. Second, merge. This is a cool step where we bake our trained LoRa adapters right back into the base model weights. And finally, step 3, deploy. Because of that merge step, what we end up with is a single, clean model that's ready to go.
And that merge step, it gives us something amazing, what some people call an inference latency-free lunch. Think about it. We get all the incredible efficiency and memory savings of QLoRa during the training phase, which is the hard part. But when we merge the weights, the final model we deploy has the exact same architecture as the original. That means there's 0 performance penalty, 0 extra latency in production. It's truly the best of both worlds. So, there you have it. That's the plan. We have the right model, we have a brilliant strategy, we have the tools, and we have a clear roadmap. We've taken what looked like an impossible problem and broken it down into a clear, totally achievable project. So really, the only question left to answer is the fun one. Now that we can efficiently customize these incredibly powerful models, what amazing new capability is this team going to unlock first? All right, let's get to work.